All right, so welcome back. Let's go ahead and keep moving on with our standard normal probabilities. All right, so you are going to be asked to find the area under a standard normal curve to the right of z equals 2.67. That is a point. And then find the area under the standard normal curve between z equals 2.16 and z equals negative 0.73. So it's a two-part question. Let's go ahead and start with the first part. So first thing you should do, if you're a visual learner like I am, I draw a little normal curve, right? And I know when it says standard normal curve that I have my mean at 0 in the center. And then I know that my deviation is always 1. So 1, 2, 3. All right, so let's mark our territory. Find the area under the standard normal curve to the right of z equals 2.67. So let's find where 2.67 is. Okay, so we'll draw a little line there. And they're asking you to find the piece that is right here. Okay, so that's the shaded area here. Okay, so to the right of 2.67. Now, we know when we use the area curve tables, right, which we started looking at in our first video, that it's always the z-score and the area that goes with it, but we know it's always from the left. So I can find out what this is right here. Once I find out what that is, that piece that from this end of the tail to this piece right here, and I know the whole thing is equal to 1, I'll just subtract out this area from 1, and that'll give me that piece. So let's find 2.67. So I'm going to go through my area charts, look for 2.67. Okay, so the area is 0.9962. All right, so 0.9962. That's this piece right here, 0.9962. And that makes sense. That's almost 99%, right? That's all of this up to there. Well, we want to know what this piece is, and we know this is 100%. So, or 1. So we could take 1 area under the curve, subtract out that piece there, and that's going to tell us what that little tiny chunk is. So 1 minus 0.9962 is going to leave us area of 0.0038. That's the piece that's right there. Okay, so hopefully that makes sense. All right, now the second part is find the area under the standard normal curve between these two z-scores. Okay, so again, I'm going to kind of strenuously encourage you to draw the curve. We have our 0. Okay, anytime they say standard normal curve, remember it's a mean of 0 and a standard deviation of 1. Okay, this time they're asking us to find the chunk or the area in between negative 2.16. So that's right here. And what? Negative 0.73. Okay, so they're wanting to know the area in between. Okay, well, we have two z-scores, but we got to keep in mind when we look up the z-score negative 2.16, that is going to give us the area to the left, right there. Then we're going to look up the z-score negative 0.73, and that's going to give us all of this area. Okay. So in order to figure out what this piece is, we're going to take this area and subtract it away from that area, and that's going to leave us the little chunk. All right, so off to the tables we go. I'm going to find negative 2.16 somewhere in this crazy chart. All right, I think I found it. 0.0154. Okay, so like 1.5% is right there. Now I'm going to try to find the area that corresponds with a z-score of 0.73. Oh, negative 0.73, excuse me. Negative 0.73. All right, that's going to be 0.2327. 2327. Okay, so we're going to just subtract. So we want this piece here right? We want this question mark right here. We know this piece is 0.154. This whole piece is 23%. So we're going to take the 23% roughly and subtract out the 1.5%. And that's going to leave us the chunk there. So 0.2327 minus 0.0154. Let's see what that chunk is. Okay, that's going to give us an area of 0.2173. All right, which is going to be this question mark right here, this chunk here. So if this whole piece is 23.27% and this little chunklet is 1.54%, if we take away this chunk away from the whole piece, it leaves us what we're looking for, which is roughly 21.73%. So hopefully that helps. Now I'm going to give you a practice one to work on. So here we go. So I want you to try this one. Find the area under the curve to the right of z equals 0.96, and then find the area under the standard normal curve between 0.47 and 1.95. So pause the video, sketch out your pictures, and then come back and see if we match. All right, so I sketched it out. It looks like they're looking for the area to the right of this, but we know that the z-score and the z-score chart is going to give us the area to the left. We know the whole thing is 1, or think about this as 100% minus 83.15%. That'll give us this chunk. But because we're working with decimals, in decimal form, 100% is equal to 1. Okay, so we're going to think about this as 1 minus 0.8315. So 1 minus 0.8315 leaves us an area equal to 0.1685. So hopefully if you've tuned back in, that makes sense. This is 83%, that's 16, 17% for a total of 100%. 0.1685. Okay, so go ahead and pause again. Maybe you've unpaused to kind of check in, and then we'll do the second one and see if we match. Okay, so if you're back, we're looking for this chunk right here. We know 0.47 z-score is equal to 0.6808, because remember, it's all the area to the left, and a 1.95 z-score. So all of this, let's draw that with like maybe a little highlighter here. All of that chunk is equal to 0.9744. So we're going to subtract the two. So we're going to take the one big chunk, the 0.9744. We're going to subtract out this piece, 0.6808, and that's going to give us that piece right there. So hopefully this is making a little more sense now that we've kind of looked at a couple examples, and hopefully you got 0.2936. Okay. So basically what we're saying is this is 0.2936, or that piece is 30% of this 100% area under this standard normal curve. Okay, I got one more for you to try because it's practice makes perfect. I'm going to pause my video, sketch this out, do the math, and then unpause. And so you don't have to forward me so much. So get to thinking about this problem and then unpause and come back and check in. So if you took care of the first problem, hopefully you got an area of 0.9898, which makes sense. That's 98.98% of the area under the curve. Hopefully you subtracted 0.0102, which is right here, away from 1. And that left you that piece to the right. Okay, so on the second part where we're looking to see, well, what is this chunk, right, between a z-score of negative 0.29 and a z-score of 1.52? Well, if we look up the z-score of 1.52, we get an area of 0.9357, or hopefully you got that, which makes sense. So from here to here is 0.9357. And then when you looked up your z-score of negative 0.29 on the chart, the area should be this piece over here. So I got 0.3859. Okay, and that is this piece right here. We're going to take the big chunk, the 0.9357, and subtract out the 0.3859. And that's going to leave us that little chunklet right here. And then hopefully you got 0.5498. Hopefully I did that right. So that was, let's see here, 2, 4, 6 kind of practice problems, getting used to kind of thinking about the curve to the right, to the left, how to use your area chart. So now we're going to step it up and turn into some word problems or some story problems. Okay, what's up? Elephants. Elephants have the longest pregnancy of all mammals. Suppose that for Asian elephants, the length of pregnancies are normally distributed. All right, so as soon as they use those words, I'm going to draw that curve. But this time they say it has a mean of 620 days. Give or take, that standard deviation is equal to 25 days. Okay. Use the table, which I use, to find the percentage of Asian elephant pregnancies that go longer than 634 days. Okay, so they're looking for the percentage of elephants that stay pregnant longer than 634 days. Now we know on average, they give birth around 620 days to a baby elephant. So we're looking for this piece here. So here is where we have to break out our, something we learned last week at the very end was how to calculate a z-score. So the z-score, because we need to know what is the z-score here. All right, once we get the z-score, then we can use the table to find the area, and then we can subtract 1, right? Take 1, and we could take away the area, and that would give us that decimal we could turn into a percent. So the z-score converter, the easiest way, I think, to write this out is you're going to take x minus x bar over s for standard deviation. So in the last video, or the video before this last one, this is the number you want to convert. This, of course, is the average x bar, and this is your standard deviation. Okay, so let's see what the z-score is that goes with 634. This is the number we want to convert. So z equals x, the number we want to convert, 634, minus the average. Well, average pregnancy is 620 days, divided by the standard deviation, which we know is 25 days. And remember on the z-score charts, each one of these z-scores go out 2 decimal places. So we're going to want to go out 2 decimal places. So here we go. Let's convert. So 634 days minus 620 days, hit enter, divide by 25. I'm getting a z-score of 0.56. Okay, so the z-score is 0.56 right there, 0.56. Okay, let's get in our Batmobiles and head over and find the area that goes with 0.56. And I see it right here, 0.7123. Okay. So 0.7123 is the area. Now remember, that's the area to the left. But we want to know how many, what percentage of elephants give birth after, so to the right. So 1 minus 0.7123 is going to give us that little chunk, okay, or that decimal. So 1 minus 0.7123. All right, well, that's 0.2877, which is that mystery area here. Let's convert that to a percentage because they're asking for the percentage of Asian elephants that go longer than 634 days. Looks like 28%. So just go 0.2877 times 100 is equal to 28.77%. And it wants us to give our answer to 2 decimal places. So in the worlds of elephants and elephants giving birth, roughly 28, almost 29% of them are pregnant longer than 634 days. I guess that's how long it takes for them to, you know, give birth to another elephant. So that was a story problem or a word problem. Let's try another one. Okay, suppose that resting pulse rates among healthy adults are normally distributed with an average of 70 beats per minute and a standard deviation of 12 beats per minute. Okay, let's draw ourselves a little chart here. Average is 70 beats per minute. Standard deviation is 12 beats. Okay, use the table to find the percentage of healthy adults who have resting pulse rates that are more than 88 beats per minute. Well, 88 is to the right of 70. So we need to know that z-score. When they say more than, we're again looking for this little chunk up here. So pause the video and use your z-score converter to get the z-score that corresponds with 0.88. Because think about this, the reason we have to convert is these tables, they don't care about elephant pregnancies or human resting heart rates. They only care about z-scores and area. That's all it thinks about. So you have to convert to its language. All right, so go ahead and convert, come back and check in and see how you did. Okay, so hopefully you're coming up with the percentage of healthy adults who have a resting pulse rate that's more than 88 beats per minute is 6.68%. So not a whole bunch of us running around with a resting heart rate above 88%. That's a very small chunk. That is that piece right there. So I converted to a z-score, found my area that corresponds to that z-score. I remember that the area is always to the left of the z-score. So because I want to know what this piece is, I had to subtract from 1. All right, do I have any more story problems for you? Yep, I got 3 more. Okay, they get a little more advanced. So let's take a peek. A race director is preparing for an upcoming marathon and estimates that the average time to finish is 308 minutes. Assume that the times are normally distributed with a deviation of 54 minutes. Okay. So we've got average to do the race is 308 minutes, give or take 54 minutes. That's a pretty large standard deviation. Use the table to find the percentage of times that's shorter than 281 minutes. All right, we'll find 281. That's going to be to the left of our average. And shorter than means it wants this piece right here. Keep in mind that your z-score is, if it's less than the average, it should be negative. So let's go find our z-score. Well, first, before we find our z-score, we got to write our z-score converter. All right. So pause the video, convert this number into a z-score. You'll know you did it right. If you end up with a negative z-score, then go find your area. Okay, so this one's kind of like a nice tasty treat because we don't have to do any subtracting, right? Because they're asking for shorter than, which means less than 281. And we know area under the curve using that table always gives you area from the left to the z-score. Well, I know that 30 or 3.3085 is that piece right there. So all we have to do to be able to put this in percentage and round to 2 decimal places is you're gonna just multiply by 100. So there's a 30.85% chance that's the percentage of people that would finish the race in under 281 minutes. So those are very fast runners there. All right. We have some two advanced problems to look at before this video ends. So let's take a look. Okay, Yoko is a civil engineer working for a city in Indianapolis, or the city of Indianapolis, on a project to widen some of its downtown streets. One aspect that she has to consider is that during the hot summer months, the noonday temperature of the asphalt on these streets can get extremely hot. For the project, she models these temperatures of the asphalt using a normal distribution with a mean temperature of 116 degrees. Give or take a standard deviation of 12 degrees. Okay, let's pop the question. Using the table, find the percentage of noonday temperatures of the asphalt between 95 degrees Fahrenheit and 110. Okay, well, 95 is here, 110 is here. They're both to the left of the mean, so we're probably going to have z-scores that are negative. We're looking for temperatures that fall in between there. So we're going to have to calculate the z-score for 95 degrees first. So remember, it's x minus x bar over standard deviation. So 95 minus 116 over 12 degrees. Let's double check that. 95 minus 116 divided by 12. Yep, negative 1.75. That's the z-score that goes here. And let's change the 110 around. Okay, because remember, the z-score chart does not care about Yoko and these temperatures. It just wants z-scores and area. So we're going to feed it what it wants. All right, so let's see if that's right. Yep. Well, I guess it would be helpful if I did that. Yep, negative 0.5. Oh, Okay, so I'm gonna go, let's see here, that's negative 0.50, which makes sense. So we're gonna have to figure out, we're gonna go to the chart and get the area that corresponds to 1.75, which will give us that. Then we're gonna find the area that corresponds to negative 0.50, which will give us from here to here, and then you guessed it, you're gonna have to subtract the two. So if I go to my z-score charts and find negative 1.75, which is right here, I got 0.0401, 0.0401, and 0.50. These parts are so much fun to dig through. Negative 0.50, 0.3085. 0.3085. Okay, so if you wanted like a big picture here, right? This piece right here is 30%, 31%. This piece right here is 4%. We want the piece in between. So it's going to be the difference between 0.308, 30% and 4%. So whatever roughly 31 minus 4% is what we're looking for. So we're going to go 0.3085 minus 0.0401, and we're going to get 0.2684. And remember, they want the percentage, and they want you to go out to 2 decimal places. So you're going to need to multiply by 100. And so we're getting 26.84%. That is the percentage of noonday temperatures of this asphalt between 95 and 110 degrees, according to this model by Yoko. Okay, one more advanced problem, and then we will stop for now. So this covers most of the homework problems in this week's homework. Yep. Okay, Yodel Air operates a charter jet service out of an airport in a secluded mountain ski resort. The chief safety officer for Yodel Air uses a normal distribution with a mean of 622 meters, standard deviation of 80. Use this table to find the percentage of takeoff distances. So these are distances for takeoff less than 594 meters. Or trick, more than 650 meters. Okay, we've not seen one like this before. This is probably why they're calling this advanced. Okay, so we're going to use this table to find the percentage of takeoff different distances less than 594 meters or more than 650 meters. Okay, let's start with this one here. So let's find the z-score. So we've got 594. So remember, it's x minus x bar over standard deviation. So 594 minus 622. Be looking for a negative z-score because you're to the left of the mean. Get something that's not negative, then you know you're probably put something in your calculator wrong. So just double check it. So I'm getting a z-score of negative 0.35. All right, this one here. Now this one's to the right, so we should be getting a positive z-score, 0.35. That's kind of weird. One's negative 0.3, one's positive 0.35. They're like evil twins. Okay, let's go find this area. So I'm going to look for negative 0.35. Negative 0.35, where are you hiding? Okay, 0.3632. Okay, so this is 0.3632, which is this piece right here. Okay, we know we need that piece. Now this is greater than 0.35. So we know we're going to do our 1 subtract, right? So let's go find what the area is of 0.35. So 0.35, where are you, Mr. Z-score? Okay, 0.6368. Okay, 0.6368. Now remember, okay, That is 63%. That's all of this. Okay. We don't want all that. We want this piece. We want just this little chunk right here. So 1 minus 0.6368 is 0.3632. Okay, so if this is 0.3632 and this is 0.3632, and we need both of them, what do you think we're going to do? You guessed it. We're going to add them together. Okay, so we should get 72.64%, and that is the percentage of takeoff distances. So 72% of them take off less than 594 meters or more than 650 meters. So that is the end of this portion of the ALEKS homework concepts that we are learning this week. I'll see you for the hardest piece in the next video. Ta-ta for now.